Hi all, today we are going to discuss our new chapter Work, Energy and Power. This slide is actually made for class 9 but it is useful for 11th class also for knowing the basic concepts related to work, energy and power. Let's start. First, what do you mean by work? In general, we can say the work is to be done when any object comes to rest or it starts moving or if the velocity changes or shape of the object changes like that. So we can consider with some examples. If we are carrying something, we can say some work is to be done, then pushing, pulling, or if we are giving some force to any objects, writing, reading. Okay, wherever we are getting tired or we are losing our energy or doing some activity, that case we can say it is a work or work is to be done. But the thing is that in scientifically or according to the scientific conception of work, work is to be done if the two conditions are satisfied. First one is a force produces motion in the body. Simply if the body is moving like without any force, um, then we will not consider it is scientific work. And if we are giving force and the body is not moving, the very good example is if we are pushing a wall. You know that if we are giving too much force also but the wall is not moving, so in that case in scientifically work is said to be not done or work done is zero. So scientific conception of work, according to that, there are two conditions. First one, the force should be applied on the body and body should be displaced. If these two conditions are take place, then only the work is said to be done. If only force or only displacement, we will consider it is there is no work. I think you got this point. So we can consider some examples when work is done. A cyclist pedaling the cycle. You know that the boy is applying force and the cycle is moving. So both the force and displacement is taking place. So work is to be done. Then a man is lifting a load in upward direction. Man is giving a force to lift that load or object and that body is also displacing. You know that what is displacement you study. The body is also moving to the upward or downward direction according to that where the man is giving force. So in that case also we can see the work is to be done. You can see some examples here. So when work is not done, can you give some examples? Yeah, when you are writing, reading, in that case actually we are doing work. Then pushing the wall, these are the situations where work is not done, because in the case of pushing the wall there is no displacement, and in the case of writing also no displacement. So these are the examples work is not to be done. Okay, now we will study in detail about what is work. So work is work done in moving a body is equal to the product of the force and the displacement of the body in the direction of force. So we can define work as work is equal to force into displacement. It's a product of force and displacement. So force we can represent it by capital letter F and the displacement by S. So work done is equal to force into displacement. Okay. So we can write W is equal to F into S, and work is a scalar quantity. What do you mean by scalar quantity? We studied in the previous chapter. If it is having only magnitude, then we can tell it is a scalar quantity. So work is generally considered as a scalar quantity. So keep in mind this equation, and work is a scalar quantity. So Unit of work. How we can define the unit of work? I told you work is equal to force into displacement. What is SI unit of force? Yeah, it is Newton, and displacement is meter. So force into displacement, you can tell it as Newton meter. Or work is also a form of energy. Their energy is consuming. So in general, we can tell that joule also. So unit of work done is Newton meter or joule. So now one of the important point, how we can define 1 joule of work, or when we say the work done is 1 joule. Suppose the force of 1 Newton moves a body through a distance 1 meter in its own direction. Then we can say that the work done is 1 joule. Or if the force applied is 1 Newton and the displacement is 1 meter, then we can tell that the work done here it is 1 joule. So 1 joule is equal to 1 Newton meter. Very important point, keep it in mind. Now, this work done, I told you that there will be a force and displacement. So always is it necessary that the force and displacement should be in the same direction? It can be opposite also. Okay, so according to that, work done can be positive, negative or zero. First we will see when work done is positive. If the force acts in the direction of motion of the body. Here you can see one girl. She is pulls that toy car with a string horizontally on the ground. He is pulling to this direction, and that um, pulling means the force is applied towards here, and the motion is also towards here. Here you can see that the both force and motion are in the same direction. Okay, if the both force and motion are in the same direction, here the work done is positive. Okay, work done is positive means when the force acts in the direction of motion, or when the force and displacement are in the same direction, we can say the work done is positive. So in this case, the equation for work done is the same equation. Work done is equal to force into displacement. Both are positive. No change. Or we can say in this case theta. Theta is means what? Angle. Angle making, both are in the same direction or moving parallel. So here theta, angle making is 0. Or in other words, we can say that if the angle between the force and displacement is 0, then work done is positive. Now, when work done is negative, okay, work done is negative when the force acts opposite to the direction of body. That means if force acts to the right direction and the body moves in the left direction. Here we can explain with an example. When the football slows down, you know that what is friction? Friction is opposed to the motion. Okay. Why the football handle, the moving football handle stops down? Because of that friction. And that friction is always acting opposite to the direction of motion of football. So here this force of friction and the motion of the football are acting in the opposite direction. So here the work done is negative. I will tell you one more example. Suppose a coconut is falling from the coconut tree. If you are considering with respect to gravitational force, they are also negative. The work done is negative. Okay. And when the work done is 0, when if the force acts right angles to the direction of motion. Right angle means 90 degree. The very good example is the moon moves around the earth in a circular path. Here you can see that the moon and the earth makes 90 degree or right angles. So here when it is in 90 degree or perpendicular direction, like I said you, the theta value will become 90 degree. Actually, when you go to higher classes, we will study the work done is equal to fs cos theta. Okay, in 9th class, usually you are not studying about trigonometry and all. What is cos? Cos values. Okay, cos 90 is actually mm, 0. So the work done here it will become 0 you will get. And in the case I told you, if it is parallel means W is equal to Fs cos 0. Okay, cos 0 is 1. So you will get in the case of parallel maximum value, and in the case of perpendicular minimum value, or it is 0. Okay, or if the force acts in the right angles. Okay, keep in mind this point also. Now, what's energy? Energy, um, it is having variety of forms and all, and you studied the energy conservation theorems and all in small classes. What are the sources of energy? You know that sun is the biggest source of energy. Most of the energy are derived from the sun, and some energies are derived from nucleus of atoms, interior earth, tides, winds, and all these many forms of energy. These all things you studied already, isn't it? Let's move to the definition, or how we can define energy. It's the capacity of doing work is known as energy. We studied what is work. For doing work, we need some energy. An energetic person can do more work, isn't it? So the capacity of doing work is known as energy. So how we can, the amount of energy processed by body is equal to the amount of work it can do. If you are doing more work done means more energy spent. Am I right? Working body loses energy, body on which work done gains energy. So the energy is also a scalar quantity. Now move to the unit of energy. The SI unit of energy is joule. I told you the generally energies are all in joule. So if it is in bigger unit, if we are spending more, we will denote in kilojoule. So how we can convert 1 joule to kilojoule? You know that if it is 1 gram, we can convert to kilogram by multiplied into 1000. So in the similar way, 1 kilojoule is equal to 1000 joule. Yes, multiplied the joule value into 1000. Then how we can define 1 joule of energy? The energy required to do 1 joule of work. How much energy is required for doing 1 joule of work? It is called a 1 joule of energy. I hope these points are clear for you. Now we can discuss the different forms of energy. Mainly many forms of energy are available. I already told you, the main source of energy is sun. The sun, you know that it is a form of light, heat, energy and all. So what are the other forms? You know, kinetic energy, potential energy. I maybe you didn't know about kinetic and potential energy, that we will study now. Then heat energy, you know, the form of heat. Yeah, chemical energy, electrical energy, light energy, sound energy, nuclear energy. Okay, students, you try to find out more examples of different forms of energy. Now, in this chapter, we are focusing mainly about mechanical energy. Okay, in physics, we will consider mainly as mechanical energy, and that the mechanical energy processed by, or the energy processed by a body on account of its motion or position is called a mechanical energy. That means mechanical energy means energy by acquired due to motion or position. So the energy acquired due to motion is called a kinetic, and position is due to is called a potential. That we will study detail, no problem. So mechanical energy in generally we can say that the sum of kinetic energy and potential energy. Let's discuss what is kinetic energy. Okay, the energy due to its motion or due to the movement of the body is called a kinetic energy. So, some examples of kinetic energy: moving cricket ball, running water, moving bullet, flowing wind, moving car, running athlete, rolling stone. These are the examples of kinetic energy. Now, potential energy. What is potential energy? The energy of a body due to its position or change in shape. So you can remember like PP, potential energy, position. Yeah, the energy of a body due to its position or changing shape is known as potential energy. Examples: water kept it in a dam, it is in a position, or that one. Then a wound spring of a toy car. Okay, so unwinding the spring due to the change in shape, or if anything is due to the position or change in shape is known as potential. Okay, so we discussed the main points related to work and energy, and it is coming the expression or equations for kinetic energy and potential energy that we will discuss in the next class. So today we discussed almost the main basic concepts of work and energy. So here is a worksheet for you. Define the term work, define one joule of work, then give an example in which a force does positive work, then give an example in which force does negative work, define the time energy of a body, then write down the units of work and energy. So these all are the things we already discussed, and we saw in the slide also. So all of you please try to find out the answer or recollect that point. Okay, now we can try to do one problem. Usually from work part, there will be asking small problems for find out work done or to find out force, displacement and all if other quantities are given. So here one problem to find out work done. We studied that equation work done is equal to force into displacement. Here it's given a force of 30 Newton acts on a body and moves it through a distance of 5 meter in the direction of force. So the force here it is 30 Newton. Displacement is given 5 meter. Okay, here I written here d is 50 meter. Okay, you make it correct. Actually the distance is given it is 5 meter. Okay, you make it correct here. Force is 30 Newton and displacement d is 5 meter. Okay. So work done is equal to force into displacement. So 30 into 5 you will get 150 joule. Okay, whenever you are doing problem you have to write down the equation and answer with SI unit. That's very important. One of the now we can discuss some of the competency based questions that we learned. Some questions based on that what we learned. So here one paragraph is given. Read the following paragraph and answer the following questions. Work done by a force acting on an object is equal to the magnitude of force multiplied by the distance moved in the direction of force. Work has only magnitude and no direction. Work done is positive when the force is in the direction of displacement, and work done is negative when the force acts opposite to the direction of displacement. Okay. Now we first question is work done is. Yeah, it's a scalar quantity. Without looking itself, we can say we studied all SI unit of work is. Students, you keep in mind while seeing joule itself, you don't take the option as A. So, like if any questions will give, you have to go through the all options first. Here you can see the Newton meter is given. You know the Newton meter is also as a unit of work or is also a unit of work. So here the option both A and B is there. So the both A and B is the correct answer. So define one joule of work. We already discussed and I'm telling one more time. When 1 Newton of force acts on a body and the body displays its position by 1 meter, then work is said to be 1 joule. Okay. Thank you all.